Hello everyone, this is a lesson on a galvanic cell. In your question paper, how do you know you have a galvanic cell if you have a voltmeter? If it's the other one, the electrolytic cell will have a battery. So this cell, chemical energy is converted to electrical energy. The electrons will move in this external circuit, then there'll be a reading in the voltmeter. So I want to just revise some of the things that you find in a galvanic cell and how you get them using the standard potential table. Okay, in your question paper, you'll be given two standard reduction potential tables. There's table 4A and 4B. Most schools, they use 4B. So we're going to use 4B as well. So what you do, you find this copper and Cr. Let's find copper, and you're going to find there are more than one copper. So we're going to find copper 2 plus. So you're going to look, find copper. This, you see, this is copper, but it's 1. This is the one that you want. So mark that, and then find the chrome 3. Mark that. These are two substances that are going to react. So after underlining them like that, the one that is on top, make sure that you're using the correct table, the 4B. The one that is on top is oxidized, and the one that is underneath is reduced. Always, you find them, the one that is top is oxidized, the one that is below is reduced. So the first thing that you're going to write is the oxidation half reaction. How do we write the oxidation half reaction? The oxidation half reaction is the one that is on top. So when it's oxidized, it loses electrons. So you're going to write exactly what they've written for you here. So it's Cr. Make sure that you don't write the equilibrium arrows, one arrow, and then it's going to lose electrons. So when it loses electrons, the electrons are after the core. But this is exactly what you write you get that in your table. Just reverse it. Remember that the electrons will be after the arrow when it's oxidized. The reduction one, we said it's copper. So it will be copper 2. The electrons will be before the arrow when it's oxidized. And then it will be copper solid. Right. Now we're going to find the cathode and the anode. The cathode and the anode are the rods and the solids that you have, the rods that will be in your electrolyte. So the anode is the one that is reduced. Look at this. It starts with a consonant and reduced starts with a consonant as well. So the cathode is the reduced one. So which one is reduced? Is the copper. The anode is the one that is oxidized, vowel, vowel. So which one is oxidized? Is the Cr. We're talking about the oxidizing agent. The oxidizing agent is the substance that causes oxidation somewhere else. It means it is reduced. When you think of it, the people that sell houses, they are called house agent. They don't live in those houses. They cause somebody else to have a house. So oxidizing agent, it causes somebody else to be oxidized, is the one that is reduced. So oxidizing agent is the one that is reduced, which is the copper ions. The copper ions, you remember the copper ions got the 2 electrons to be copper solid, so copper atoms. So oxidizing agent is that element that is, or that substance that is reduced. The reducing agent is the substance that is oxidized, is the substance that causes something else to be reduced. So what is oxidized? When you look at here, chrome was oxidized. So it is the reducing agent. So that's your reducing agent. When you get a question that says calculate the EMF of the cell, the formula is in your formula sheet. The EMF of the cell is E of the cathode minus E of the anode. So you take your table, you find the E of the cathode which is 0.34 minus E of the anode, which is minus 0.74, and then you calculate that. You get in your table on that line that you drew, you get that in your table, and then you take your calculator, you add, you get 1.08 volts. So it means this battery will produce 1.84 volts. Okay, let's look at the last one. Right, if you are asked a cell notation, you're gonna write the anode solid. So here our anode solid is Cr. Then we have to write the phase as well, and then the anode in the aqueous solution, in the solution, so it's Cr plus 3, and then we have to write aqueous. Then this is the salt bridge. The cathode in the aqueous solution is copper plus 2. You have to write aqueous, and then the cathode solid is copper, then you write the S. This is how you write the cell notation. This is the end of our lesson. Thank you for watching.